Today we're going to be looking at composition of linear functions, and we're asked to find value. So what I want you to think about is something called a turducken. And a turducken is exactly what it sounds like. It's actually a chicken inside of a duck inside of a turkey. And when we're looking at composition of functions, we actually work from the inside out. So just like the chicken ends here and it goes inside the duck, well, when we look at a function, this would be our chicken, the G of 5, inside the duck. And that's just kind of another analogy to kind of help you, or if you can think of those little Russian dolls, where you have one little Russian doll inside of slightly a larger Russian doll, slightly inside of a larger Russian doll. It's the little one that goes inside the bigger one, that goes inside the bigger one still. So what we're going to look at is G, which is function G of x, and we're going to put it inside the function f of x. And then we're going to evaluate that for the number 5. And I'm going to show you two different ways to do this. First way I'm going to show you is the straight composition of functions. So I have number 1, f of x is equal to 2x, and g of x is equal to 6x. So if I have f of g of 5, what that means is I'm going to take g and put it inside of f. What does that look like? So I would say f of 6x, and where I see x right here, I'm going to put the 6x instead. So that would be 2 times 6x. Well, that gives me 12x. And if I evaluate that for 5, that would be 12 times 5, which would give me 60. That's one way to do it. The other way is to just go ahead and evaluate g of x for 5. So I would say g of 5 is equal to 6 times 5. Well, that gives me 30. So I'm going to take 30 and I'm going to put it in the f of x function. So I'm going to say f of 30 is equal to 2 times 30, which gives me 60. So if you notice, I can go ahead and compose the function first, then take the value that they're asking for, put it in, and get an answer. Or if I prefer, I can go ahead and evaluate the inside function for whatever the value they're asking. In this case, it was 5. Get an answer. Take that answer and put it inside of the first function. So our answer here would be 60. All right, let's look at number 2. So I've got find f of g of 0. So again, I'm taking g and I'm putting it inside of f. So I could say, all right, I'll just write down what it says here. F of x is equal to 6x plus 1. G of x is equal to 3x. So I would say, okay, I'm going to put, I'll write down here, f of 3x is equal to 6 times 3x, because I'm taking g and put it inside of f, where I see the x, plus 1. That gives me 18x plus 1. And then they're asking me to evaluate that for 0. So 18 times 0 plus 1, that's 0 plus 1 equals 1. That's one way to do it. The other way, let's go ahead and evaluate g of x. So we're going to evaluate g of x for 0. So that means where I see the x, I'm going to put in 0. So 3 times 0 gives me 0. So then I take 0 and I put it in the f of x function. So f of 0 is equal to 6, and where I see x, I'm going to put 0 plus 1. That gives me 0 plus 1, which is again 1. Alright, let's go ahead and take a look at the next one. I'll go ahead and draw a line here. Split my page. So, alright, here's our next one. We've got find composition of f of g when the value that we're putting in for x is -3. And I'm going to continue with my thought here where I do it both ways. So I'm going to say f of 4x plus 2, because remember, I'm putting g inside of f. So that equals 5, and where I see the x, instead of writing x, I'm going to write 4x plus 2. And that gives me 20x plus 10. And I'm evaluating that for -3. So that gives me 20 times -3 plus 10. That's -60 plus 10, which would give me -50. And again, the other way to evaluate is to say, okay, well, I'm going to take g and I'm going to put -3 in place of x. So I've got 4 times -3 plus 2. That gives me -12 plus 2, which gives me -10. Then I'm going to take this answer and I'm going to substitute it in the f of x. So f of -10 is equal to 5 times -10. Well, I was writing the answer already. 5 times -10, which gives me -50. Alright, let's move on. This time I've got the composition of Q and R, where the value of x is going to be -3. So again, I'm going to take the inside function and put it inside the outside function. So I'm going to say Q 5x, and where I see x, I'm going to put 5x in its place. So I've got 20x plus 2, and that's 20 times -3 plus 2. That gives me -60 plus 2, which is -58. Alright, and over here, I'm going to evaluate it as if I already knew the number. So I'm going to say R of -3 is equal to 5 times -3, that gives me -15. Then I'm going to come up here to Q, and say Q of -15, because that's my answer, is equal to 4 times -15, oh, I wrote 5, -15 plus 2. Well, 4 times -15 is -60, plus 2 equals -58. We'll move on to the next one. We've got the composition of Q and R, and the value of x is 2. So again, I'm going to put the inside function, which is R, inside of the outside function, which is Q. So I've got Q, where I see x, I'm going to write x plus 2. So that gives me 4. And notice this whole thing is together. It's a binomial. So you have to put that in parentheses so that you can make sure you distribute correctly. So we've got 4x plus 8. And we're going to put in the value of 2. So we've got 4 times 2 plus 8. It's 8 plus 8, which is 16. Then again, if you like it the other way, go ahead and evaluate what you have here. So we're going to do r of 2 is equal to 2 plus 2, which is 4. Then we're going to evaluate our outside function, which is q, taking the input from our previous function, which is 4. This is what we call the x, the input. And then we're going to substitute where we see x. We're going to substitute 4, and that gives us 16. Let's move on. We're asked to find the composition of C and D when the value of x is 0. So again, we're going to take our second function, our inside function, D, and put it inside of C. So we've got C of 2x, because that's going to be my input. And then I do 3 times 2x. So wherever I saw the x, I put in 2x instead. And that gives me 6x. And now I'm saying, okay, when x is 0, what is my answer? So 6 times 0, obviously, is 0. So again, we can evaluate it the other way, where we go ahead and evaluate our function d of x. So when x is 0, what is d of x? Well, 2 times 0 is 0. So then we're going to take the value of 0 and put it inside the c of x function. So c of 0, which is the answer to the previous function, is equal to 3 times 0, which obviously is 0. Alright, I'll do one more. Alright, although we have two linear functions here, we're going to continue with what we've been doing. So we're going to take our inside function, which is the g of x, and we're going to put it inside the outside function, which is f of x. So we say, okay, f of what? Negative 4x plus 5. And where I have this equation here, instead of x, I'm going to put negative 4x plus 5, close my parentheses, and then put plus 1. Distribute, so I have negative 16x plus 20 plus 1. That gives me negative 16x plus 21. And we're saying evaluate this function when x is 3. So I would do negative 16 times negative 3 plus 21. Well, that's positive 48 plus 21 would be 69. So now let's kind of check it here, because this one is a little bit more involved than the ones we've done. So we're going to do g of negative 3, and that's negative 4 times negative 3 plus 5. So that gives me 12 plus 5, which is 17. So this becomes the new input for the f function. So f of 17 is equal to 4 times 17 plus 1. Now I'm going to do this over here because I don't know what 4 times 17 is. So 17 times 4 is 8, 2, 6 plus 1, 69. So this was 68 plus 1. That's equal to 69. Alright, you try to take it to 100.